Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we're gonna cover integration for our next topic. So most of you know that integration is just the opposite of differentiation. We have covered differentiation last time. You know how to differentiate. So the opposite process of differentiation is what we call integration. So for example, if we have this function 1 over 3x cubed plus c, where c is a constant. If you differentiate this, 3 you bring in front, and then the power you minus 1, so 3 over 3 becomes 1, and then you're going to have x squared. So constant c, if you differentiate, will become 0, right, regardless of what number it is. So this is what we have done last time, differentiation. So now we're going to learn how to integrate. Most of you have done this already. So for those who have not, it's not that difficult to follow. So this video lecture will be based on the notes that I have given you a few days ago on integration. So it's best if you can print that notes and go through with this video lecture. So for integration for your level pre-U1, you will be covering these 6 major points. It's very easy, far easier than O-level. Okay, so the first one we will cover the integration of a simple polynomial function 𝑎𝑥 to the n, and then application of integration on finding the equation of the curve, and then we will do integration of composite function, right? And then we will cover definite integration and another 2 applications of integration. But today we'll cover these first 3 points. Alright, so the first thing that we need to know is how to integrate the simple polynomial function of 𝑎𝑥 to the power of n, where a is the constant and x is the variable. So first thing is that you need to know how to write the notation correctly. It is very important for you to know how to do this. So let's say if you want to integrate 𝑎𝑥 to the power of n, you should write it as integration of 𝑎𝑥 to the power of n. dx means with respect to the variable x. So how do we integrate this? So you just follow this formula. So you have constant a here, so you just set it aside, but don't erase it. It's still there under the operation of multiplication, right? So just set aside the constant. Now look at x to the power of n. So the power now, you plus 1 instead of minus. Okay, so you plus the power with 1, always plus 1. And then you divide the whole thing with the power, n plus 1. That's it. Then you always need to write plus c, because this is an indefinite integral. Okay, later we will do definite integral, so you will know what this means. Right? So here are a few straightforward examples that you can follow. So if you look at the first one, dy over dx equals to x to the power of 3. So the question asks you to find y. You know that if you differentiate y, you will get dy over dx. So the opposite way is, if you integrate dy over dx, you will get your y. So writing the notation correctly is very important. So you know that y, we can get y by integrating dy over dx with respect to dx. So what is dy over dx? It's x cubed. And then we go to the process of integrating. How? So the power, you plus 1, and then divide everything else with the power, with the plus 1. Then you plus, then you simplify. Alright? So done. So the next one, let's try the example C. So you have dy over dx equals to x times by square root of x. So this is just indices. Simplify this into this term. Alright, so when you want to integrate it, just plus 1 and plus 1. Done here. So you have to know, again, you have to have the adequate mathematical skills, algebraic skills, and indices skills to change from this form into this. Okay? So if you have a constant, if you want to integrate it, for example 100, if if you want to integrate 100, it's just, it will become 100x, that's it, plus c. Okay, the reason behind it is explained here. So for example, we want to integrate 3 with respect to the x. So this is not a function, this is a constant. You know that x to the power of 0 is 1, so we can express it like this. So if you apply the integration formula, so you're going to have 3x 0 plus 1 divided by 0 plus 1, which is 3x plus c. Okay, so any constant, if you want to integrate it, just put x, right? Right, so now you know how to integrate a basic polynomial function. We're going to spend a little bit time to discuss on rules for integration. Okay, so let's say we have a function k multiplied, a constant k multiplied by a function fx. So if you want to integrate this, we can take the constant k outside, set it aside, but do not erase it because it's still there under the operation of multiplication. So with that, we can just focus on integrating the function fx. So for example, if you have the integration of minus 3x to the power minus half dx, minus 3 is a constant, you can take it outside, right, or set it aside, but we have multiply here. Now we can just focus on integrating this, right? So integrating it, blah blah blah, right? So you have this. Simplifying, you get this done. So that's the first rule. Right, so the second rule is if you have the integration of a function with more than 2 terms, for example, integration of fg plus or minus gx dx, so we can separate this by integrating it term by term. So integration of bracket fx plus minus gx cross bracket with respect to x, we can express it like this: integration of fx plus minus integration of gx. Okay, so for example, if you have this function, now if you look at this function, it looks complicated, but we only know how to integrate a simple function. So try to find a way to modify this expression by simplifying using algebra expansions or indices into simple expression. So here you can see that if you can separate this, simplify, then we'll get this. We're not integrating this yet, we're just changing the expression. So now we can express it as for x minus 3x to the power minus half dx. Okay, so using the rule here, we can separate this as integration of each term, integration of this one and integration of this one. Okay, if you look at here, you have minus 3. Using the first rule just now, I can just take it outside, alright, because now it's meeting with the negative, become plus 3. Okay, so it's easier for you to integrate it. Then you integrate it term by term, simplify, then you'll get this answer. Okay, so the next part is the application of integration, which is finding the constant of integration and the equation of a curve. So this is quite straightforward. It's just an addition for your coordinate geometry, right? And differentiation also. Okay, so for example, so you can just read these examples. It's very straightforward and explained in detail here. If you don't understand, please ask me. Right, and then the next part is the indefinite integration of composite function. So we know what is composite function. Okay, for example, 𝑎𝑥 plus b to the power of n, where a and b is a constant and it is in terms of x. So if we want to integrate this, we just need to follow this formula. So the integration of composite function is a little bit weird because you need to do differentiation a little bit. Okay, so let's try and integrate this. So 𝑎𝑥 plus b bracket to the power of n. So the power, you just plus 1 as usual, and then you divide by the power plus 1. Okay, then you have to multiply with the differentiation of ax plus b, which is a. That's it. Right, and then you have to plus c because it's an indefinite integral. Okay, we'll do examples so you can understand better. So if you look at this first example, 2x minus 3 to the power 4, this is a composite function. So how do we integrate it? So the power, you just plus 1 becomes 5. Then you divide it with the power plus 1, which is 5, divide. Then you multiply by 2. Where do you get 2 from? The differentiation of the inside function here. 2x minus 3, and differentiate, you get 2. Then you plus c, that's it. Alright, so the next example, we have this. So you have to rearrange this, it will become this. Okay, so the constant 20, you can set it aside if you want. So how do you integrate this part? You just plus the power, you just plus 1 becomes minus 5, and then you divide it, then you multiply it by the differentiation of the inside function, which is minus 4. Simplify again this. Okay, as you do a lot of examples, you can get better and faster. So the last part for composite function is where you need to solve problems by using hands, meaning the previous question. So I will cover this tomorrow, okay, because this part is a little bit confusing. Okay, so for today I want you to focus the materials that we have discussed before. Alright,